Good afternoon, everyone. Welcome to the third talk at the Fall 2025 CSS Seminar Series organized by the Center for Computational Social Sciences of Koç University. We're especially excited today because this talk really sits right at the intersection of the seminar series core themes, computational and AI-based methods, political polarization, and the wider societal implications of emerging technologies. It is therefore a real pleasure to host Professor Christopher Bale, whose work has really shaped both academic debates and public conversations on these issues. So before I give the floor to him, let me very briefly introduce him to you. Professor Bale is professor of sociology, computer science, political science, and public policy at Duke University, where he directs the Society-Centered AI Initiative and co-founded the Polarization Lab. His research examines how artificial intelligence shapes human behavior, with a particular focus on social media platforms and political polarization. He's a Guggenheim Fellow and a Carnegie Fellow, and his work has appeared in leading outlets including Science and Nature, as well as venues such as the New York Times and Harvard Business Review. His 2021 book, Breaking the Social Media Pyramid, received wide acclaim. It was featured by major outlets including the New York Times and the New Yorker and described as masterful by Science. And the book also helped spur real-world impact, including changes to platform policies aimed at countering misinformation and polarization. Beyond his research, Professor Bale has played a major role in building the field of CSS. He is the editor of Oxford University Press Series in Computational Social Science and a founder of the Summer Institutes in Computational Social Science, which provide free training to early career scholars worldwide, as some of you may know. He also serves on the advisory committee of the National Science Foundation's Social, Behavioral, and Economic Sciences Directorate and helped create Duke's interdisciplinary data science program. Professor Bale earned his PhD from Harvard University back in 2011. We're delighted to have him with us today. Without further ado, Chris, the floor is yours.
Thank you. Thanks so much for that lovely introduction. It's so nice to meet all of you. I quickly saw some names I recognized, and I know you mentioned the Summer Institutes, and I see Akin there is
Hey,
um,
Chris.
how you doing?
Good,
It's
good.
great to
How are
see you,
you?
my friend. We are so excited to be running another location with you guys, and the Istanbul site has been a real shining spot of the community, and just want to give a shout out to all of you who are making that happen or who made past institutes happen. Yeah, it's a pleasure to be here today. I admire a lot of what's coming out of Turkey that I've been able to read, and far from an expert in the region, so you'll have to forgive me for a lot of, I guess, the typical American thing to do, a focus on America at the exclusion of the rest of the world. But I'll be interested to hear whether you think some of the material I present today resonates or does not resonate. Um, I should also say this is kind of a weird talk in that it's not really an empirical talk where I'm trying to make an argument that generative AI can or cannot improve social science. It's really more of a survey of an emerging literature. And the talk is based loosely on a piece I published 2 years ago with the same title. And I mentioned 2 years ago because a lot has changed since then as well. And a lot of the evidence I'll present today is not peer reviewed or was in the preprint stage when I first reviewed it. And so I don't, unfortunately, won't be able to give any kind of authoritative answer to the question I'm posing here today, but I'll try to at least, stimulate a conversation. And again, would love to hear more about what you think and whether you can help me fill in the details. One of the things that I think is so difficult about this moment in computational social science is things are changing so rapidly, and it's really hard to keep up with everything that's going on. So I suspect at least one of the issues that I discuss here today one or more of you will have something to say about or say know the literature better than I. So yeah, so to start off with, every talk has to have a foundation model generated image. And as you can see here, this title slide sort of vaguely approximates a lot of things that might be relevant to social science. We've got pictures of people, we've got some charts here, but on the other hand, it can barely spell. And there's a lot of strange imagery in here that's sort of like difficult to parse. And I think this is sort of quickly a metaphor for where we're at. There's a lot of excitement, a lot of hype. I think, as is typical in the hype cycle of new technologies, there's also a wealth of criticism. And so I'll try to strike a balance between the two. And I should mention, I can't see the chat. So if someone could interrupt me, if there's something like you can't see my screen or something like that, if one of the organizers could interrupt me or pass along comments as you think they might be relevant, that would be great.
Sure.
Um, Thank you. I think this QR code is still working, but it might not be. I think I put this up before I discovered that Bitly, Bitly's Bitly's QR codes can go dormant. So I'll just leave up the link for a minute so you can screenshot it to grab the link to these slides or the link to the paper that I just mentioned if you want to follow along more deeply. And I'm happy to share these slides with the organizers afterwards as well. I hope most of the links in this presentation still work. I should have checked before this presentation. Apologies for that. So I'm going to start with what I think are the most potent opportunities for research, computational social science research with generative AI in particular. And then I'll move on to what I see as the biggest challenges. So I'm going to sort of split the survey into a few different research areas. They're not presented in any particular order, but the one that I think many of us have already begun to experiment with is some form of automated text analysis with generative AI. And I should probably start with a brief definition of generative AI. By that term, I'm trying to make a distinction between sort of predictive machine learning or artificial intelligence, where the goal is to predict an outcome given a large training set, to models that generate de novo text, images, music, and other types of output in a probabilistic manner. The canonical examples here being things like ChatGPT, Claude, Nano Banana, all the new Vanguard Foundation models. So one area where there's quite a bit of excitement, I think, is in automated text analysis. And computational social scientists have been at the vanguard of natural language processing for a while now, working on things like word embeddings and topic models, and before that, just simple dictionary classifiers. And so there's sort of a logical interest, or an obvious interest in what LLMs can do in this space. And there's a number of nice papers now. One of the first most systematic analyses I discovered was the work of Caleb Zeems and Dee Yang. At the time, they were at Georgia Tech, and now they're both at Stanford. And this was simply a survey of the capabilities of LMs in terms of reproducing categories um, applied to text by scholars in 6 different fields, which you can see at the top here, and a variety of different subfields, ranging from sort of toxicity prediction to misinformation and event extraction and history, and at different levels of analysis, from utterances to or parts of a sentence, for example, to conversations to entire documents. And mostly this analysis is just zero shot prompt formatting. So we're just saying, we're not giving any examples of what we want to be classified. We're just saying, for example, which of the following leanings would a political scientist say the above article has? Liberal, conservative, neutral. And we just put all that data into the LM, and we see in this paper how well it recovers the codings of human coders. And if we look at, sort of typical scores which balance the false positive versus false negative rate, we see here that, overall, the models seem to do pretty well, especially in political science, psychology, and sociology, and especially if we look at the utterance level and not the document level. And this was one of the first papers, I think, that, for me anyways, suggested, okay, we're really going to want to scrutinize these things carefully. And I think now, we're seeing more and more scrutiny, as I mentioned. And of course, we can look at other types of data sets as well. This is a paper that was published by Steve Rothier and others um, from NYU, and they were trying to determine whether LLMs could reproduce the categories of linguistic inquiry word count, a well understood dictionary based classifier that developed by James Pennebaker, which was designed to see whether one could easily extract psychometric properties from text, um, learning from the actions of human behaviors and creating a dictionary which assigns sort of different sentiments or other kinds of categories of human behavior to a term. And basically what you see here is the overall, accuracy scores of various models. We don't have GPT-5 in here or, the most recent Gemini or most recent Claude, but, GPT-4 representing, I think many people believe, something of a turning point in terms of the capabilities of the models. We see a clear improvement on the baseline established by GPT 3.5 Turbo as of April 2023. The interesting thing about this graph, I think, is that we see the models beginning to show promise in non-English contexts, and especially some relatively um, less often spoken languages, or at least less well represented languages on the internet, like Hausa or Swahili. And I now realize that Turkish is on there. So you all have to tell me whether these are reasonable assessments. But when I read this paper, I thought, interesting, but in theory, these tools unlock a new kind of cross-language analysis for those who lack language-specific skills if these results were to hold. And we could argue that you might argue this is a low bar, or or a not the highest bar maybe. But I thought, again, it was early evidence that there's some promise for these tools. Then we could begin to compare in this paper, which is linked at the bottom, human ratings to the for each of these to the GPT-4 ratings. We see, the models seem to be doing about as well as human ratings across different models. And at the very least, seem to be an improvement on the dictionary methods, I think one could argue. So, again, early sort of promising results. Um, you know, I was once presenting these results. Sorry, I meant to go back. I was once presenting these results, and a young graduate student asked me, if you are at the beginning of your career, given these results, should I still invest in learning about natural language processing? And my initial reaction was, of course you should, because, like many of us were trained using, these kind of relatively now older techniques, and it's useful to learn how a large language model functions in order to understand its limitations. And to do that, you would at minimum need to understand things like word embeddings and tokenization and all the processes that go into building these kinds of models. But it did make me wonder after the talk, for the casual user or user who really is just trying to extract features from one study, can we now say that, they could reliably use an LLM based on these early papers? I don't think we're there yet, but I think it's some promising evidence that we're moving in a direction where we're beginning to understand some of the capabilities. And I think, having now experimented with these tools myself a bit, I can only share anecdotally that it really seems to depend on the classification task and the data itself and the model itself and the combination of all three of these things. So again, I wouldn't I wouldn't advise this student to avoid conventional training in these areas. But I do think it's worth many of us experimenting with them. And I think like another question that I'm often asked, and I suspect a lot of you have thought about, is like compared to something like a topic model, like how does an LLM do? And I think we're going to see in the next few years a number of interesting discussions about those kinds of topics. And also maybe hybrid topics where we, for example, use LLMs to label topics produced by a topic model and things like that. Um, again, I think probably some of you are aware of more recent papers that have looked at these kinds of things, but for the time being, it seems like a bright spot. Second area that got a lot of early excitement, and I think Lisa Argyle's on your list of visitors, is that right? Further down later in the semester. I think Lisa is a longtime collaborator of mine, and she sent me this paper about 3 years ago that presented evidence that LMs might be able to impersonate humans in the context of typical public opinion surveys. And if you've not seen this paper, it's now published. The link is at the bottom of this page. And again, apologies for the American focus, but this is the American National Election Study. This is the study that we use to typically understand, pre and post election behavior. And here, what we're seeing is like GPT-3, so a relatively early model, prompted to answer the same questions that humans were, given a persona that is derived from some empirical observation, like demographics, usually. And basically, the size of these little circles describes, the prevalence of words people use to describe the other party. And, this graph in particular sort of suggests that, the models were pretty good at mimicking human behavior. Again, the model here is like prompted to take the survey just like a human would. And then once you begin to look across race, gender, age, education, patriotism, political interest, all these kind of typical things that many political scientists in particular might care about. I was, when I first read this paper, like very surprised how well the models were doing. I think now we know a lot more, and you know, people have struggled to reproduce these results in other contexts. I think most relevant, maybe to this crowd, is the more recent work that's tried to look at this internationally. So Etienne Olian, who's a social scientist at École Polytechnique in Paris, led a really nice paper trying to basically replicate this analysis for the World Values Survey, and showed that, I think in that paper, which I think is still a preprint, or at least I'm not sure whether it's been published, that the models seem to struggle in other contexts, and in particular, that the models tend to homogenize populations, especially populations that are not well represented in the training data. There's a number of other interesting papers that I'm sort of glossing over here in this space. And if you check out the paper that I linked at the beginning, you'll see my best attempt to review that literature as of about 2 years ago. But at the time, there was a number of papers, including a particularly interesting one by Santurkar et al. At Stanford, who had prompted a large number of models to take a large number of surveys. And there's like sort of a wonderful visualization in that paper that basically shows something that's not too surprising in retrospect, which is that the models tend to evince the opinions and preferences when they're not prompted carefully and calibrated to impersonate a single person of people who built the models, meaning like left-leaning, younger people from San Francisco Bay Area, right? Now, there's so many interesting attempts to, study these in other contexts. I think the Prism Alignment Project is a really interesting example, which is a paper that, won one of the NeurIPS Best Paper Awards last year, I think it was, or the year before. We're learning a lot rapidly, and I think what many groups have started to conclude is that though there was like a lot of early excitement, it seems like these models tend to again, homogenized populations, and that might not just matter for less well represented groups, but even if, like someone mentioned at the beginning, polarization. And, if you're interested in the variance of opinions across a population and the models tend to homogenize, basically, if we think of LMs as statistical prediction machines, right, it's sort of like it makes sense that they try to approximate some kind of mean population level behavior. And so, in the case of research on population, there's other research that, for example, shows that models probably underestimate the variance of the distribution of responses to questions. So that even if you can accurately guess the mean for a population, you might underestimate the variance in it or overestimate the variance depending on the group, and that may lead to mistaken conclusions. So I think, like, early on, I don't think Lisa Argyle or anyone any of the authors of this paper were suggesting that LLMs could somehow replace human populations. Even in this early period where there was a lot of excitement, they were still warning, this is probably most useful for testing the viability of surveys or pre-testing hypotheses and things like that, but we're not, anywhere near the place where we can replace human respondents. Though it is perhaps worth noting the increasing concern about the prevalence of bots or use of LMs among survey populations themselves. And so to some extent, we may be studying bots even if we don't want to. So there's, new and vexing problems that I'll get to towards the end of the talk today too. But it's just interesting that LMs seem capable of, approximating human populations with all the caveats I just gave. So third area, I think there's a lot of excitement is in sort of synthetic experimentation. And so here, a lot of early work would, for example, take some classical experiments in behavioral economics, like, for example, the work of Danny Kahneman, and prompt LLMs to read the same vignette that respondents in one of Kahneman and Tversky's early survey experiments took. And then we basically can estimate treatment effects on these synthetic populations and compare them to human populations. And so here, the goal isn't so much to approximate the attitudes of a population, but to see if LLMs or other kinds of foundation models could serve as surrogates for humans in experiments in order to estimate treatment effects. One of the most interesting papers I came across in this early period, and there are a few. I mean, there's been a bunch of work in this area now. There's a team in psychology, which I think since I published this paper, their paper came out. There's a group at MIT that focuses specifically on behavioral economics. There's a number of European teams too that have been looking at this. But this paper really caught my eye. This is a paper by Hewitt et al. The senior author here is Rob Willer. And they had this kind of interesting data, which is the test archive of experimental data sets, which was these data that were collected some time ago. And basically, people were given free internet access for participating in a lot of social science research. And it used to be that, if you could petition to get your survey experiment on one of these panels, and if you did, you could, potentially, get a sample of 600 people, 1,000 people. And there was a competition, and it was sort of a well understood data collection mechanism that facilitated, I think, something on the order of 700 experiments over, I think it was about 10 years. I might have those numbers not quite right. But what's interesting about these data sets is, like, there was an opportunity to assess the capabilities of LLMs outside of very well understood treatment effects. Like, Danny Kahneman's book, Thinking Fast and Slow, is the best-selling academic book of all time. So we should not at all be surprised if LLMs have learned to evince or have learned to demonstrate or exhibit the behavior that one could read about, like, literally all over the internet, right? But a more interesting challenge is, like, well, if there are, let's say, unpublished studies or studies that are much less much less prominent, how would the LMs perform given, like, same thing, same prompts, reading the same vignette, looking at the same picture, whatever it is? Um, can we then compare the treatment effects of a synthetic population to a real human population? And that's what this paper, which, and I was thinking right before I logged on, I don't know what the current status of this paper is, whether it's been published or not, but it was getting quite a bit of attention a few years back. And once again, like the results are pretty impressive, I thought. So here's the correlation between the actual um, randomized controlled trial treatment effect on the y-axis here, and then GPT-4's predicted treatment effect based on priming the LLM in exactly the same way the humans were primed. And that correlation is really, really strong. It's 0.91 for all effects. Interestingly, panel C here looks at just unpublished studies. And naively, I would have thought that the correlation would be less strong for unpublished studies if the models had, in fact, just learned the treatment effects, from like a Danny Kahneman study. Instead, if anything, the correlation seems to maybe even get a little bit stronger, although it's such a small difference that we probably shouldn't make that statement. We could probably even we might be more accurate just to say that it doesn't seem to be um, just the mere fact that studies are published that explains this difference. Now, there could be other things like maybe studies aren't published because they sort of just reproduced well understood effects and therefore we're not so different. Or it could be, some kind of publication bias around null effects. Who knows? They tried to get at a little bit of this in panel D here, looking across fields, looking at whether or not a GPT model could recognize the authors, things like this. And there seems to be some difference, but overall, it seems to still have a pretty strong correlation, even despite these kinds of considerations. Interestingly, the model comparison and on panel B here, once again, just like we saw with automated text analysis, it seems like the models do better. The newer models do better. This is a totally anecdotal observation, but I have personally, and comparing notes with other computational social scientists, started to see some evidence of scaling laws sort of no longer holding beyond GPT-4. So a lot of us, I think, have been interested in why that might be, and I can't point to a paper. It's just sort of an anecdotal observation, but my hunch is that GPT-5 would not be much better than GPT-4. It's an empirical question, but it's just purely a hunch. But I think it's worth pausing on because it would suggest that either humans are a lot more predictable than we realize or a lot more complex than we realize, and both outcomes seem equally plausible to me anyways. Um, this team also built this app which allows you to, run your own synthetic experiments, which I thought was kind of interesting. And once again, I don't want to speak for these authors, but in discussing this paper with them, I don't think they would say that, again, we need to get rid of human research. Their argument is instead that these types of techniques might open make experimental research much more accessible to a larger group of people, or much like the synthetic survey stuff, allow us to do some kind of prima facie evaluation of the viability of a research hypothesis, or especially if we can run the experiment, dozens or hundreds of times, some kind of confidence bounds about which type of treatment effects are most likely to produce, impacts on human populations. Again, I think a lot of people would be very concerned if we only use these methods. So we're still, I think, very much experimenting with them, but it's an early part of the literature I'm keeping my eye on. A third area where I've been doing quite a bit of work recently, and unfortunately don't have much to share from our recent work, so I'll have to describe it a little coarsely here, is just full-blown agent-based models. So like here we have created a social system with artificial agents like we might have 10, 20 years ago. If familiar with this, again, I know a lot of people are interested in polarization on the call, a model that tries to predict the emergence of like echo chambers when you give agents some preferences or some degree of influence over each other, and the models sort of work through some kind of interaction over time. And we're asking questions like how quickly does polarization emerge or not emerge. And an obvious limitation of these models is they don't really process language. And one could argue that, a more high fidelity representation of human behavior would enhance these kind of simulations, and you might get closer to something approximating human behavior. And that was sort of the idea behind this paper that I wrote with Petter Tornberg, which tried to simulate a few hours of Twitter, a small part of Twitter, by calibrating agents derived from the American National Election Survey, the same data set we were discussing earlier, which also measures the frequency of social media usage and the types of social media platforms that people use. And we use these to generate personas. And then we used an RSS feed to simulate the news cycle, and we prompted the models to read the news according to their self-reported interest in the news. We asked them to post according to their self-reported frequency of posting. And this creates a sort of a synthetic social media timeline. And then we prompt the other agents to read that timeline and comment on it, once again, according to their self-reported, social media behaviors. And then we, through this process, generate something like an artificial social media feed. And now there are many more efforts in this space. At the time I published the paper linked at the beginning, I think I counted something like 10 or 12. And now I'm sure there's many more than that. But basically, the sort of interesting idea is like, if you did this, could you try to reproduce a field experiment, not just a survey experiment like we were looking at earlier? Like, for example, in this 2018 paper, in this Twitter experiment where we paid people to follow bots that exposed them to content from the opposing party, we found that this tended to actually increase ideological polarization or issue-based polarization, especially for Republicans. And so, like, could you see that in the data, or could you experiment with new types of algorithms that are difficult to convince a social media platform to implement, like this kind of bridging algorithm idea that I um, was interested in developing some years ago, and had some modest success working with Twitter in one small part of its platform, which was then called Birdwatch, to implement the platform. But it's much more interesting to think about it at the level of the entire news feed. And so if you create these synthetic environments, perhaps you could run experiments that are impossible to run in real life, or unethical to run in real life, or on sensitive populations like the dark web, and where it's nearly impossible to run experiments. And so there's a sort of a thought experiment, to what extent is this possible? And so in this paper, we tried to create different types of networks, and we tried to do these different types of interventions, and then we used the LLM to assess the behavior of the LM, which I think, there's some issues there. You'd much rather have humans validate all these things. But this was sort of just a proof of concept kind of paper. And we thought at the time, like, this seems to be working. And we were excited enough to write a large grant application and to spend the last 2 or 3 years trying to reproduce these findings with much more rigorous evaluation methods. And the our conclusion so far has been that we were a little optimistic, or maybe very optimistic. And as we held the models to more increasingly strict tests with, for example, data that link social science surveys of real populations to behavioral data, and try to use these more rich data to both validate and prompt models, at least for the smaller models that we're able to work with, and we have to work with mostly open source models that we can run locally because of privacy issues with these data. We're seeing that, the models are, they're okay, but they're not quite as high fidelity as we might like. And there's this interesting question which I don't quite know how to answer, which is like, how close do we need to get to actual human behavior in order for these models to be useful? Because it really depends on the sort of the epistemological approach to agent-based modeling. If you are in the all models are wrong, but some are useful, view of the world, then maybe we're getting more useful models. But an entirely different perspective would be to say that we are adding unnecessary complexity. And the beauty of agent-based modeling is that they're actually very simple and parsimonious. And so if we can observe emergent behaviors that we have theorized with very simple models that are very interpretable, then why are we adding all this noise with LLMs? And I like, in my view, that's sort of where we're at with the ABM literature. There's people arguing sort of both sides of that, and I think they're both very reasonable arguments. And I don't know any way that we will broker those two competing views anytime soon. But I do think it's an interesting area that is at least worth continuing to explore. And hopefully we'll be able to post a paper that reports on this more rigorous study that I just developed, that I was just describing, hopefully in about a month or two, if you're interested in this kind of stuff. And I'll skip over some of the more fine-grained results. These are just showing that in this early paper, we think we created a lot of content that seemed plausible, but again, we didn't validate it carefully. So I tend to think it's probably not anything we should hang our hats on. We need to be more rigorous. Okay, so we've looked at automated text analysis, synthetic surveys, synthetic experiments, and sort of synthetic agent-based models. I guess all agent-based models are sort of always synthetic, so let's call them generative agent-based models. But the area that I'm personally most excited about is blending simulation and human experiments. So if you've done a lot of experimental research, like it's expensive, it's logistically difficult, can create ethical issues. It's difficult in particular to get groups of people to participate in an experiment at the same time. It's expensive, logistically difficult, and all these different things. And so one area that I've become really interested in thinking about is like, well, could we create an artificial environment where a human interacts with a group of agents? And so this is one of about 12 papers that the Depolarization Lab has been working on in this space. For the last 6 years, we've been building something that we call the Human AI Research Platform, or we used to call it the Social Media Accelerator. And the idea was to create different types of social media environments. So you could think of things like different features. So for example, like one platform might have a like button and the other doesn't, or one platform might have engagement-based ranking of content in the news feed, but another might not. And that you could rigorously evaluate the impact of those kinds of features on our platform, which enables randomized control trials. So you can basically, a researcher has some thesis, some hypothesis, and we recruit people who want to participate in a study. We tell them typically that they're helping to test a new social media platform that's not yet been publicly released. And we give them an invite code to install an iOS or Android app. And then once they do that, unbeknownst to them, that invite code randomizes them to either a treatment or control condition. And then we collect in the app, which integrates Qualtrics, pre and post social media experience questions. It also enables fine-grained behavioral data collection, things like that, we social media researchers in particular often can't get even when we work with social media companies like dwell time or impressions or all these other kind of very fine-grained behavioral data. We can also ask people for permission and consent, which is something that has been, a key issue in a lot of field experiments. Obviously, it doesn't simulate the sort of full-blown uh, you know real world social media environment, but we think that it's an interesting alternative to the available modalities. I see another question coming in from the chat. Again, I'm not able to monitor the chat, so if there's something urgent, please just interrupt me. So the key thing, getting back to the topic, is that here a real human respondent from this population is actually going to, on this platform, not be interacting with other humans, though we have done that as well in earlier experiments, but large groups of agents. So in this paper, which is linked here, we were looking at the impact of instead of having like a verified badge on a social media platform, what would happen if you had like an open-minded badge? Could you change people's behavior to make them more open-minded, make them more kind and all these kinds of things, like engender some kind of pro-social behavior. Um, Another good example, a paper we have forthcoming in the American Journal of Political Science looks at exposure to incivility. So in this synthetic feed, in one condition, people see sort of, relatively civil content. And then in the treatment condition, we prime the bots to be modestly uncivil. So don't think like hate speech or super toxic stuff, just a little bit less civil. And it allows us to test hypotheses like people's willingness to post and then also attitudinal data like their comfort with posting and things like that. And what we discovered in that paper, we think, is that when people are exposed to incivility, they don't like it, right? They would prefer they feel less comfortable posting, but they actually post more often. And when they post more often, they tend to post more toxic stuff. So we think this is some kind of like spiral of toxicity, if you like. And that's the kind of question that social science is often about, like how group behaviors shape individual behavior, which is one of the hardest things to run experiments on. So one thing that I'm particularly excited about is like if you can get groups of agents to approximate group level behaviors, then you can potentially look at a much broader suite of questions around human behaviors. So, a really important question is to what extent do people know that they're interacting with bots, and to how well do these bots impersonate actual people? Now, we can prompt them to impersonate panelists from the American National Election Survey, or we can prompt them even with data from our own past experiments in principle, though we haven't done exactly that. Um, what we find though is when we give people a question in our surveys, like how many bots did you interact with on this platform, the vast majority of people think they're not interacting with bots. So whether the agents faithfully reproduce human behavior is one question, but it doesn't seem to sacrifice the validity of the experience from the respondent standpoint, at least according to that question in our surveys. Um, this is what I was describing earlier about sort of being able to manipulate things like the features of the platform. We can also manipulate the content itself. We can again manipulate the agents and give them different characteristics and things like that. So this was sort of the glass is half full description of the state of the field, and I think like many people would argue the glass is half empty, right? Like that, there are just as many new challenges as there are opportunities. And, even though I'm personally excited about these blended hybrid approaches and think of this as a continuum where we can move back and forth between simulation and conventional research, and perhaps, create a new sort of cycle of science where we prototype things in synthetic realms and then move to fully human experiments or vice versa. Um, there's going to be so many new challenges. The first, which I've already discussed a little bit, is sort of the bias of the models. Right? Like we're all very well aware at this point. And as I mentioned earlier, the models tend to, exhibit the behaviors of people who are well represented in the training data. And probably that shouldn't surprise us. This is the paper I mentioned earlier by Santurkar et al., which looks at this large group of models and a large group of survey takers. And this is the visualization I was describing earlier, where we see, the models just tend to in these are earlier models, right? Da Vinci and some of the earlier um, you know, Vanguard LMs, but you just see pretty clearly that they tend to lean left and they tend to under or poorly approximate the views or tend not to express the views of rural populations or elderly Republicans in the case of the US. Again, once again, this is unfortunately a very US based example. Now, again, these models weren't prompted to impersonate these populations. We're just asking them um, what the model thinks about a particular question, then comparing that to the population. Here's the other paper I was mentioning earlier by Etienne Olian's group, which uses world value survey data. And again, so much of the evidence here is not yet peer reviewed, so like we have to be really careful. But my concern is if we don't begin to review or keep our eyes posted or keep keep apprised of preprints that like will just miss so much of the most, recent evidence. And the journals I think are really struggling to keep up, or at least those that I work with and review for. And here we're seeing basically what I was talking about earlier, the sort of homogenization of the population. So the human populations are in yellow here, and the models are all the other colors. And this is what I was talking about earlier, where we're seeing that the models tend to underestimate the variance in the data. They tend to just kind of a regression to the mean, kind of, as you might expect, to the extent that you can think of these things as sort of statistical average machines. So there's bias. In addition to bias, there's this homogenization. And then, of course, a big concern for people who are big fans of open science is replicability, because the very nature of these tools is that they're probabilistic. And even though we have perhaps some ability to control how stochastic the behavior of models are, with, say, temperature parameters, fundamentally, we should expect them to produce different results each time we prompt them. So, if we ask, I think I don't remember which model I was using when I made these slides, but if we ask, I think it was probably ChatGPT, can generative AI improve social science, on 6 times across 6 different days with 6 new chats, right? We get very different kinds of responses, some more optimistic than others, some certainly using different words, some acknowledging limitations, others not, right? And if you can imagine a naive approach where we're just trying to, you know, approximate the opinions of a large group of people, and we ask the LMs to impersonate different types of people, well, like probably we should take some average of their responses if you're concerned about these kinds of things. And of course, human populations themselves are inconsistent, right? Humans change their responses to questions too. So this is kind of this interesting question of like, to some extent, the probabilistic nature of responses is part of the tricky part of validation. And like when I was talking earlier about this, the struggle to validate the behavior of models in the context of agent-based models, like one reason that's so hard is like we're really bad at predicting what humans would say at baseline, right? Like, or at least I can't predict what people do on social media. So why should we expect a large language model to do it? So in other words, we might be using different yardsticks or measurement paradigms to evaluate the tools and holding them to too high a standard or too low a standard. But the probabilistic nature is a fundamental problem for creating replicable research. And of course, there's like best practices, but at some point, if we use these models, we just have to accept that they're going to produce different results. There's new ethical issues. This is like an area that I think is again, especially in computational social science. As Matt Solganic wrote in his bit by bit book, there's always unknown unknowns, particularly in computational social science, and a lot of well-intentioned projects wound up creating, really unfortunate outcomes. And so it's important for us, as ever, I think, to be really sensitive to what new types of issues could arise. I've already mentioned informed consent and those types of things. But creating digital twins of people, is that, there's certainly ethical questions there. This is ChatGPT's horrifying depiction of the ethical dilemmas related to generative AI and social science research. It's interesting though, because I was sort of, when I was writing this article that's linked at the beginning of the slides, I was thinking, oh, wow, there's going to be so many new challenges. And, usually my experience is usually reviewers, are, eager to jump in with criticism. But here, the reviewers surprised me and they're like, actually, this may solve some ethical problems too. And I was like, huh, I hadn't thought about that at all. But like one example I can offer in my own research is, in the past, we used to do research where we'd have multiple people use one of these social media platforms we built. And the challenge there was like, if those two people start harassing each other, which happens rarely, but does happen, right? We have to staff essentially a content moderation team to track all of these conversations unfolding over days on the platform we built. And it's really tricky. And the hazard of someone being exposed to hateful rhetoric, one could argue, is probably higher if you used human populations compared to relatively steerable and controllable LMs. I'm sure we've all experienced, LMs going off the rails, but for the most part, depending and especially for particular models, like we seem to be able to control, especially more recent models, and with much more fine tuning and much more human oversight, the range of behaviors that we might expose people to. So that's kind of an interesting trade-off, and I hadn't thought about that at all until this reviewer sort of, offered that observation. But certainly impersonation, there's a host of new issues related to disclosure of exposure to AI. So, for example, do we need to tell people when we expose them to AI? I think a lot of people would say the answer is yes. Is there something about preserving the nature of humans that is just fundamentally, um, some kind of IRB concern? But even beyond institutional review boards, do we just owe respondents some kind of, disclosures in this area? It's another area. And there's many more that I describe in this paper linked in the beginning. Another area so many people are worried about, rightly so, I think, is just sort of, junk science and hallucination. So here, the model's just sort of making stuff up. And I think the problem with hallucination has been, if our opinions were frozen in 2023, then we would be very, very concerned about hallucination. I think my sense is more recent models have done a lot better at avoiding hallucinations, although it's certainly still a problem. And, there's no way for a model to really know the truth, capital T. Um, I do worry about the proliferation of junk science, people submitting grant applications written by LMs and, reviewing papers with LMs and, like just LMs on every part of the scientific process could, in theory, create some kind of model collapse situation where, you know, um, science sort of eats itself in the worst way possible. Now, of course, there's an optimistic take here, which is that, um, science will be emboldened by or empowered by LLMs, and scientists will be emboldened to take on new questions or discover, you know, research questions and hypotheses that have been hidden by human biases and or our lack of, time and patience to sort through carefully all of the different permutations of theories that could unlock a certain outcome. And, certainly there's examples from computational biology which are exciting, but in the space of social science, it's not yet clear that there'll be that kind of payoff. It would be interesting to see. There's some good work going on. Dashun Wang in Chicago has a few field experiments in this space. Di Yang has a few experiments in this space. My colleague Boyuan Chen at Duke has some interesting experiments in this space. James Evans has some interesting recent work and paper that just came out yesterday, which he presented here a few months ago, that suggests actually AI is a net positive for most scientists' career if we, depending on how we define AI. So I don't want people to run away with that and say, and I don't think James would either, but it is something that I think is worth keeping our eyes on. And here's an example of the hallucinations, right? Apparently, I created Dolly, according to Llama, which is, I can promise you, not true. Environmental impact, really big deal. I think many of us are concerned about the training costs, the inference costs of using these models, especially if we do things like run thousands of simulations of humans, populations, what is the trade-off there? Like, at what point should we be carefully considering the environmental costs of these models? Now, these costs are really difficult um, to actually interpret in real world terms. I think there's a real lack of transparency, but these are training costs, and inference costs are much, much lower. And a lot of people recently have been scrutinizing some of the more sensationalist claims in this space. But it seems that there's at least a non-ignorable environmental impact, if not a significant one. And so we should all be thinking very carefully, not only about how much and when we use um, generative AI, but also which models we use and whether we should be using them locally or whether, and there's some really interesting recent advances in this space too. The new model by Ateash Zurich, which is like a fully open source campaign, which I think is really interesting. It's called Apertus. If you've not yet seen it. It's basically a LLM for science and for scientific research that is more or less open source. And can be run locally and performs really well in a lot of actually in some of our simulations is one of the better performing models. Again, that paper hopefully we'll be able to post in about a month. Um, the the other thing is like innovations at the hardware level, which usually social scientists aren't talking much about, but here at Duke, um, some of my colleagues have created first of their kind data centers, which use the heated wastewater from GPU cooling technologies to power other things on campus. So there are innovations here, and hopefully we'll get better. But again, as we're all considering when and how to use LMs in our research, it's just a final thing to think about. And I'm sure there's many other challenges and limitations I've left out. I think again, if history is our guide, and going back to Matt's book, there's going to be unknown unknowns, and so hopefully many of you will surface those. But I think, and I didn't get to talk a lot about other issues I describe in this paper, like for example, the closed nature of so many of the models and the lack of access to data and our lack of access to data on real human populations using LMs. And these are all things that are very familiar. If you were part of studying social media in the early days, right, it's always tricky to get these kinds of data for many good reasons related to privacy, user experience, and so on. But we're sort of back in a very similar spot, and I think therefore it's really um, incumbent upon social scientists to think about whether we need to create our own infrastructure for social science research, and that's one of the reasons why I took a moment to flag Apertus, the ATH Zurich large language model, as something to potentially explore. But more broadly, just sharing data sets, sharing, again, in the best version of open science, sharing everything we know in order to figure out more quickly where and how to use LMs most efficiently in our work. So that's all I know about this topic, or most of what I know about this topic, and would love to hear what you think.
Thank you so much. This is a really inspirational talk, and we have a lot of our students in our CSS program. I'm sure they really benefited a lot from it. So before I open the floor, oh, actually, there is a question in the chat box. So I'll just read them out loud, and we can maybe collect a round of questions. And
Sure.
all right, so let me see. Shukru is asking. Shukru, by the way, is one of our dear research assistants who've been really helpful in organizing the CSS seminar series.
Cool.
Uh,
Yeah.
he is asking, in your preprint, you discuss LLMs built by social scientists. How would these differ from
Mhm.
standard LLMs? Do you mainly mean models that are less biased or tools trained on real survey and empirical data?
Yeah, it's a really good question. I'm just linking some stuff in the chat here that is relevant, and I mentioned. I think the issue is just like we don't understand the fine-tuning phase very well, right? Like, and if you think about the way that I think, and who knows, but I think, or I understand most, you know, Vanguard proprietary LMs are trained, it's for customer service and user experience, right? Like, so we're fine-tuning these things to be useful agents and to be helpful and all these kinds of things. And very likely some amount of the bias that we see in the models is coming out of that fine-tuning stage. And for social scientists, bias can be useful. Like we sometimes want to leverage bias or at least be able to detect it in a raw form and control it. So when I was first envisioning this, I was thinking of like, if we were to create a raw model, um, it could be useful to understand the direction of the bias and to be able to control the bias in a more intentional manner rather than trying to sort of reverse engineer where the bias comes from, which is what I think we're at. And that's so hard to do because of the lack of transparency of the model builders right now. So I haven't gotten deep into Apparatus, this tool I just shared in the chat, but it is I think one area where we could potentially do that kind of thing. I also shared, by the way, the paper that looks at the exposure to incivility in case anybody's interested in that. But it's a great question.
Thank you so much. Shukra also reminds me that we'll be listening to Julian next month in our seminar series. And as we
Cool.
also
Yeah.
mentioned, Lisa Argyle will be speaking in the seminar series, but these are the spring semester.
Right, right. I saw. Yeah, that's great. Yeah.
We have a bunch of actually questions, but I think they all want to ask that unmuting themselves. So I'm just going to give the,
Great.
okay, let me see. I'll give the floor to Akın first, and we'll take it from there.
Okay.
Sorry, my screen is there, my cam is here. So I think my question is related about this rabbit hole that we're all in. Like, what does it mean to be a social scientist in the
Mm,
computational age? And
yeah.
you end with this idea that like future AI systems will need something like a social sense. And I think
Mm,
I found this like really compelling. Like, could you elaborate
mm,
on what you think constitutes that capacity? Like, is it mostly about learning statistical like regularities in human behavior, or do you think it
yeah.
also involves things like shared norms, like role
Yeah.
expectations, context awareness? Like,
Yeah.
do you have
Yeah.
like a Turing test in your mind that would allow us to kind of,
We,
yeah,
yeah,
like, what do you think?
we have well, I have a paper with my brilliant graduate student Ben Rocheford, which is called a sociological Turing test, and I'm trying to see quickly if we have a preprint online. I believe we do. Let me just see if I can get the link here. Yeah. Um, so it is a little bit of it's probably a little premature to call it a sociological Turing test because a sociological Turing test would require the ability to detect all those types of things you were just describing, Akin, like norms, roles, all these sociological concepts. And in this paper, we're really just looking at how people classify people as a bot or not according to social identity cues. And so one interesting thing we find in that paper is that maybe unsurprisingly, a lot of social identity biases kick in when we ju make judgments about who is human and not human online. And those are both the typical ones you'd expect. So like majority groups tend to classify minority group members or at least outgroup members as more likely to be bots. But among minority groups, at least in this experiment we ran, minority group members tend to classify other minority group members as more likely to be bots, we think is really fascinating. And it plays into something like sociologists have called double consciousness, going back to W.B. Du Bois and others, and Goffmanian dynamics of stigma and all these kinds of things. And so, you know, we can't know that that really is like a social sense in the way that I think the truest sense of the term. And when I use that term, I was trying to conjure up the spirit of the comparative historical sociologist Bill Sewell, who like wrote these wonderful books on the French Revolution and this kind of like this broader argument that there's this ineffable thing that humans have, right? Which is this sense of what one ought to do in a social context, and yes, that's partly guided by norms and roles and all these kinds of things. And the way that we've so far tried to validate these models is just like, what do you think of this policy? What do you think of this group? What do you think of and that's sort of like gesturing towards things like norms, but it's not like looking at how the agent would behave in a real setting, So like to me, like you hear the term agent thrown around so often, but to me, like the real opportunity social scientists have, and here I'm talking less about the intellectual pursuit rather than like the progress of AI in itself. It seems to me that if like agents are to go off into the world, into complex social systems and try to navigate things like a financial market or a university or a healthcare system, right? They need this kind of social sense of like when you ought to say something or not say something, or who you ought to interact with or ought not to interact with, and all these kinds of things. And there, I think you're right that we need some kind of new validation. And this paper that I was mentioning earlier, where we're trying to validate the social media or predict social media behavior, or at least compare the LLM generated behavior to human behavior, you know, um, is far off. I think it's really far off. So I think if, to the extent that we have concrete theories that would predict how people interact in social settings. And maybe you mentioned role theory, which I think is a really nice one, right? Like that, right now agents are just sort of unmoored from a social relationship, right? They're just sort of like, again, as we were discussing earlier, probably some kind of statistical average machine, right? So if you think about them as connected and you give them roles and you give them repeated memory of exposure, right? Like these are the kinds of things that it'd be interesting to compare to a human population. I don't think anybody's done the validation where we compare like a network study to an LM network. That would be really interesting to do. I'm probably wrong and probably someone's done it. I only mean that I haven't read it and would like to read it. But it's a good question, one that I can't really answer any better than that.
Thank you. I suggest we collect a round of questions because we actually have a lot of questions in the chat box, so we'll have enough time to at least have a quick response to each. Berke, we'll start with you, and then Aybike, and then Nima.
Thank you. First of all, my question is related to reliability, but in a different sense. So, since these LLM models are designed market-oriented, not necessarily research-oriented, there are a lot of updates. There are new models coming out every second. You pick a model, you validate it, you use it in your research, and before you finish your manuscript, there are a bunch of new models out there. And
Yeah, that's true.
sometimes the models change behind the scenes as well.
Yeah.
What does it say in terms of replicability, you think, and longevity of
Mhm.
the research that you know, for the next 5-10 years of this research field? What would be the implications that you think?
Yeah, and earlier when Sukra asked about the why we need our own model, I think this is like another area where I think we could do better, right? Like I think you're exactly right that the models are changing in ways that we're unable to observe. And the like a vivid memory I have, like early days of LMs was Arvind Narayanan, the Princeton computer scientist, I think is like always super smart and on, just in this space in general, and someone I enjoy reading. And I was reading his book at the time, and there's all these points on bias, and so I think I was then reading his Substack or something like that. And one morning he had complained about LMs tending to use male pronouns when prompted to describe a doctor, right? Or some kind of early evidence of like gender bias in LMs, right? Which is totally unsurprising if you followed this space, right? In fact, a six group, a Summer Institute's group, in 2018 wrote a really nice paper diagnosing the same problem with gender image classification in Google and stuff like that. So not surprising. But later that day, I mean, like literally 5 hours later, someone from the company that produced the model in question was like, "Yep, we just fixed that problem, like this afternoon, like an hour ago." So it's like, it is a constant feedback loop, right? In ways that we can't detect, and so I think like that's why having our own model seems really important, one that we can at least understand, and again, to some extent, begin to learn how to drive and steer. But yeah, I do worry about that. I think like I think the question too is like, if we replicate an experiment, we don't expect the exact same behavior to happen in the replication, right? That would be naive. So to some extent, again, like I don't think we need every LM to behave exactly in the same way in order to generate meaningful replicable science. The tricky question is, where is that point, and I don't think we have established that as a field. Like how much difference, how are we going to evaluate that difference? Those are the kinds of things that I think like if we can get some best practices there, someone could write a paper just like how much would LM behavior have to change in order to make results not replicable. That would be a really useful paper, one of you could write. Yeah.
Thank you. Aybike.
Mhm.
Thank you so much. First of all, thank you
Sure.
for the presentation. It was a great honor to see you live like this. Actually,
Oh, thank you. That's too kind.
my question is connected to Berke's question. So generative AI tools, as far as I know, do not guarantee full protection regarding all kinds of information like data, hypothesis, or even
Mhm.
model use. There's a lot of things that we cannot, control like updates. So I think problems regarding information leakage and contamination
Mm.
becomes especially important. And I think this also brings out the problem of ownership and control, between the
Hmm.
researchers and owners of these tools, especially the firms,
Yeah.
even between the human subjects. So
Hmm.
how do you think that we can approach and take action regarding this situation? And did you experience such a problem in the field?
Yeah. Yeah, I do. I mean, as I was mentioning at the end of my talk, I do worry a lot about this issue, like mostly based on my experience with social media research. I mean, I'm old enough to have been like, part of that first wave. I don't know, Akin, I think we're about the same age. Maybe you were also benefiting from this moment where, the data was just all over the place, right? It was kind of like the wild, wild west, everybody was scraping data and like data was freely flowing everywhere. And it was
Exactly.
like, it was a fun time to be a social scientist, but then very quickly everything changed, and like, it became more difficult to access Facebook data, and then in certain platforms like Google sort of never really shared much data, right? Or Instagram. And what lessons did we learn? I think one is a hard lesson, even though we may feel like we deserve the right to access that data, we don't have a legal right. Right? We don't act, we have like maybe a moral claim, like, and especially like Dean Freelon, you can still watch on the Six YouTube channel in 2018. He had this very prescient talk that he gave was called the end of the API era, like API, application programming interfaces, which we, use to collect so much social media data. And his claim was that, we're seeing less and less access, but that we have a moral imperative to continue to collect the data if technology companies aren't going to create safeguards against social harms, right? And that is a real reason why we should continue to do our research. At the time, I was a little uncomfortable by the argument just because like the legal questions, I mean, if you're a young graduate student embarking on a dissertation and you collect a bunch of data and then you get a cease and desist letter from a bunch of lawyers, that's not a good outcome for you either. But I think more fundamentally, the challenge was we lacked a intellectual trading zone between industry and academia. We became very quickly strong critics, and one could argue a lot of that criticism was warranted. But the result of that criticism, especially when it wasn't empirically calibrated, right? Especially when people were just making sort of normative claims, like I think this algorithm is radicalizing people, and I know because of this one person I met, right? Like inside a company that just has a very polarizing effect. People say, okay, well, you're now a liability to us, right? You're not giving us a way to fix that problem if it even exists, right? You're just sort of throwing stones at us. So I think making things a shared problem to the extent that we can, easier said than done. But we had the CFO of OpenAI here recently, uh, Sarah Fryer. And I know her actually because we collaborated when she was at Nextdoor and we did a field experiment that Lisa Argyle and I, based on a paper that Argyle and I wrote a few years back using LMs for conflict mediation. We were able to implement that in a field experiment with Nextdoor, the social media platform that like people use to connect to their neighbors. And she was speaking on behalf of OpenAI, and she was basically look, we don't like. Someone asked her like, what keeps you up at night? And she said, honestly, it's these safety issues. It's the all the safety issues. And what was interesting in hearing her talk a little more about is like OpenAI actually doesn't want that responsibility. Like they're taking it seriously. I don't want to like I'm not making a criticism, but I'm just saying like they would prefer for the government or academics to take on more responsibility in evaluating, assessing safety issues and preventing them maybe. And so I think the more that and the one thing that gives me a little bit of hope, although I think this is probably one of the more naive things I'll say today, is that a lot of these companies are fundamentally led by researchers. So, like OpenAI, for example, it in early days of Meta, researchers were not in charge. Like they were sort of a useful luxury for these companies to have, but they weren't like viewed as like key to the success of the organization. Whereas in places like Anthropic and OpenAI, my impression is, at least in the early days, researchers had a lot more influence, and researchers, by their very nature, appreciate things like open science and the need to tackle safety issues. I fear, though, now shifting out of optimist mode into pessimistic mode, that especially as these enormous investments have been made in these companies, that we're going to see the researchers become quickly overshadowed by the people who are able to help the companies make money, which I think, you know, hastens the urgency for creating our own models for social science research, as we were discussing earlier. So it's a great question. Again, like one I don't have a great answer to, can only speculate and share that past experience.
Thank you so much. Um,
Sure.
so we have Nima next in line.
Thank you, Professor Hagen, and thank you, Professor Bell, for this wonderful presentation. I recently went through your interview with Gary Newhoff and also your presentation at Cultural Network for AST Advocacy in Northwestern Institute. That was back in 2017. So I was
Okay.
going through all of those videos. So in that presentation, you had highlighted that current limitation of testing sentiment or variance of messages. So I would like to get your perspective on how this newer LLM's development is capturing the audience perception, both on the prescriptive and the descriptive side. So if we
Okay.
have access to this social media APIs, which is itself a separate question. So do you also see the good prospect in the low resource language settings in conducting that kind of research?
Yeah. Yeah, I'm sorry, I don't remember that talk very well, so it's hard for me to remember the context, but I can only say that I'm just really not an expert on this issue. I think asking maybe Julien that question, because he's looked at, less less regularly used languages, or Steve Rothie, or any of the people on that paper that I shared in one of those first few slides. Like, I think they would know much more. I mean, almost all of my research has been in English, I'm afraid to say, so I can't give a good answer to that question. It wouldn't surprise me if there are significant limitations. And of course, you mentioned sentiment analysis, which, as we all know, is like a pretty coarse tool to begin with. It's like I think it's it's what sentiment means, and what, who's creating the training data is always the sort of the rub with these kinds of issues. I can say that a lot of the off-the-shelf methods, my collaborator Petter Tornberg, at University of Amsterdam, did some analysis of the Perspective API tool, which Google recently announced it's going to sunset. But it was, I think, for a long time, one of the, standard models for detecting toxicity, for example. He has a number of analyses. I think he has some papers posted about how biased it is towards English. And I think even in like German, a relatively, large language group, like it shows all sorts of different bad properties. So yeah, unfortunately, I can't answer the question confidently. I'm sorry.
I will continue with the questions in the chat box, but before I do that, I have a note from Akın. He had to leave us, thanking you very much for this wonderful talk, and to us for
Oh, cool.
inviting you. And he also left the QR code of SI CSS Istanbul.
Nice.
Shameless advertising, he says, but we're really
And I
happy.
don't know, just to make sure everybody knows, these are free programs, that are designed to provide you high quality training in computational social science, as well as interdisciplinary research opportunities. There are typically, there's typically an admissions process, and I don't know exactly how that's set up, but I just wanted to make sure everybody knows it's free. We work hard to raise the money to keep them free, but so that it doesn't put a burden on students.
We're joining forces with Özyeğin University and Sabancı and Boğaziçi University.
Cool. Oh, that's great.
Actually, we did it 2 years ago, and then we took a break. So we're going to be back with this collaboration. We'll be
During the earthquake, if I remember correctly. Yeah.
so
Yeah.
Akın also joined the board, and so without his input, we decided that we would wait until he
Right.
came
Sure.
back. So that's how it's gonna go, but we'll be
Cool.
posting.
That's exciting. Yeah.
Um,
Thank you for all your work on it.
we thank you very much for
Oh no, I have a very small role compared to you all.
thank you. So one question is okay, let's from Ardam. Chris, there is a growing worry about cognitive corrosion in academia. LLMs can speed up lit reviews and writing, but it can also do de-skilling of scholars
Hmm.
and students over time. In your view, what are the best practices and perspectives so we can capture big productivity gains without eroding intellectual capacity in teaching and research?
Yeah, it's a great question. I mean, offhand, I would have thought this is an area where LMs could really excel, right? Like information retrieval, summarization, like it seems like given the nature of how these things are trained and the nature of an embedding space that they should really excel in these kind of areas. I linked the syllabus to a class I taught last semester, which was trying to see, really, it was a survey of how LLMs are doing in automating science. So we did this sort of group project. We were trying to figure out, to what extent, where in the social science pipeline are LLMs most useful. And there's a number of papers linked on there. I can't in real time sort of flag the most important ones, but there's at least two papers on there that try to reproduce systematic literature reviews. So they have like a human-led lit review, and then they ask the LM to do the same lit review and try to do a systematic analysis. And they don't do a good job. Really, like surprisingly, in these now, some of these papers are 2 years old, so maybe in the last year things are better, maybe not. But the question that I think is most important is like why are they not doing well? And there could be at least two reasons. One would be the models just can't do this, even if they had all of the best information and all access to all the best documents. Another would be that there's no model that has access to all of science, like the Web of Science plus Elsevier plus Archive plus all the things, right? And I myself have played around with tools like Elicit, which I found to be really useful. Like when I first used it, I was like, wow, this is quite shockingly good. But then, of course, it was missing things like you'd expect. But more recently, I discovered like they don't have access to Web of Science, which is where, depending on your field, especially if you're in certain fields, that's a huge problem, right? So it's frustrating because like it's a theme with so many other areas, like the things we would like AI to be really good at, right? Like the menial work of science, like reviewing literature or data cleaning and stuff like it's actually not very good at least according to these studies. There's another really interesting study linked on this syllabus that's a psychologist at Harvard, and I'm blanking on her name, but she did a multi-stage study where it's like the LM automates each stage of the science process. And she found similarly, disappointing results, literature review, really bad at data analysis, causal inference, those kind of things. But there was a surprising part of that paper too, if I remember it correctly, which is like so she had this validation technique where like human raters compared the human work to the LM work. And human raters rated the ethical review of the LLM as higher quality than the human review. So like again, areas that you wouldn't expect, right? And if you think about it, like it sort of makes sense because an LM we discovered, Lisa and I, we think we discovered in that paper I was just describing about conflict mediation that LMs are really good at perspective taking, right? They can distill the perspective of from lots of different angles, right? Which humans are really notoriously bad at doing. So maybe for something like reviewing whether something is ethical, it can take the perspective of different people, assuming it's not biased and all these other things, right? So it's not, but we too are biased, right? So like, how do we, and we tend to see the world through the lens of researchers and not the populations we're studying. So again, it's sort of like, for me, it's tricky because I think somewhere in this article I have a line about how it's like self-driving cars. It's like on the one hand, the idea of a self-driving car is amazing and it creates all these conveniences. But if you have to hold your hand over the wheel of a self-driving car constantly while it's driving itself, then what's the point of a self-driving car, right? Like, and I think that personally, I worry a lot of my own experience with LLMs is like this, right? So it's like it's done a literature review, but then it missed that one article that turned out to be really important, and I had to go find it, and that took me just as long as it would have, if not longer, right? And that's not a good outcome.
Thank you. Um,
Sure.
okay, going back to the participants, Ilayda, you can go next.
Thank you. Hi, Professor Bale. Thanks for being
Right.
here.
Sure.
I am actually one of the graduate students from Koç's program of CSS, and
Cool.
I have
Mhm.
also like a kind of engineering background and used to work in like research companies and also like worked in FMCG. So my question is coming from like this weird mixture. So,
Sure. Yeah.
like in brand research, we generally segment audiences by their behavioral patterns, like
Mm.
heavy users, switchers, early
Right.
adopters, etc. And
Hmm.
like one of the studies you mentioned suggests that like we could like create LLM personas even like
Yeah.
for each segment to simulate
Hmm.
their like reactions to
Hmm.
different scenarios, as far as I
Hmm.
understand. So I am curious about where this approach reaches its limits.
Mm.
Like could segment-based simulation give us valid insights for like lower stake situations like brand strategies, and also like
Mm.
could the same methodology scale like the higher stake mass phenomena how can I say predicting how different population segments respond to like different political decisions or like
Yeah. Yeah. That's
coordinated
interesting. Yeah.
misinformation campaigns, etc.
Yeah.
So what are your foresights about this like thresholds,
Yeah.
either like ethical or technical?
Yeah. It's really interesting. It's a good question. I think in some sense, like we're so bad as social scientists in assessing heterogeneous treatment effects, right? Like that different types of interventions tend to have different effects on different populations, right? We often just assume there's one treatment effect. And so like if we think about segmenting audiences in the same way as we think about heterogeneous treatment effects, then I'm tempted to say like, well, maybe that's an area where we could at least detect the possibility of heterogeneous treatment effects if we had intentionally very segmented audiences and that kind of thing. I don't know anybody that's done that work or, the work on causality and LMs there's a lot of interest. My general sense is like people are generally disappointed by the results, but like perhaps that's because we've been looking for one treatment effect. And perhaps LMs, especially larger LMs, like learn these sort of like bizarre, again, like heterogeneous treatment effects. That would be really interesting to know. The other way of responding to your question that I can offer, and I can't offer, once again, this is one I can't offer very well because I don't study like segmented audiences very often, but a sort of parallel question is about tailoring different types of messages to different types of audiences. And there's a lot of people doing work on this. Dave Rand has some nice papers looking at, tailored advertising and tailored sort of micro targeting and stuff like that, which seem to suggest that. And I think Rob Willer has a new paper on like targeted campaign donations. Like they seem to be really good at it. So that's both cause for optimism if you want to like help nonprofits raise money, but also cause for concern if you're concerned about like targeted misinformation campaigns or, misleading campaigns. So yeah, it's a really good question. I think unfortunately I'm not the best person to answer it. I think reading some of that work would probably be more productive than listening to me.
Okay, thank you.
Yeah, sure.
Thank you so much. We're already past our time, but if that's okay with you, we still have two more questions.
I'm
Um,
happy to do one more. Unfortunately, I have a student waiting outside, so I can't do more than one. I'm so sorry.
okay, that's okay. So, I will give the floor to Emre then.
Cool.
Hey, so thank you for the presentation, Professor Bale. It was really informative. So
Thanks.
very shortly, we use LLMs to measure, political ideology, moral language, emotions, etc. from text, but
Mhm.
it looks convincing on paper because it produces fluent labels. But in social science, we care about construct validity, whether the measure truly
Mhm.
corresponds to, the underlying psychological or the social
Yeah.
construct. So, what would convince you that an LLM-based construct actually has construct validity and not just high face
Yeah,
validity?
yeah, it's a good question. I think like, it's sort of like this deeper question of like, attitude, behavior, consistency, for example. Like we're only expressing the attitudes and the behaviors were sometimes we do sort of behavioral econ experiments like I was talking about. And there's a lot, there's some interesting, I haven't followed the debate too closely, but there've been a number of papers recently on like behavioral games and like agents playing, Prisoner's Dilemma and that kind of stuff. And maybe those would offer some more construct validity if you're concerned about like the disconnect between attitudes and behaviors. And what's interesting there is like I've only followed the literature in a fairly superficial way, but like one group seems to say yes, they definitely can, they behave like humans in behavioral games, and another group seems to be saying is actually they really don't. And I haven't read either groups closely enough to have an opinion on who's right, but that's very familiar now, right? Like a lot, it tends these literatures tend to be bifurcated in how people experience the capabilities of LMs and stuff like that. So I don't know the answer. I think I have a deeper concern though, which is like behavior defined as like playing a game online is very different than behavior in person, and like earlier when Akin was asking about like the social sense and these more micro level interactions, right? Like LM is are not yet like embodied, right? Like they're just talking machines, right? They're not agents in the world really that are, that we're interacting with in physical space. And so I think especially if you were looking at things like eye tracking or, like physiology and all these kinds of things, right? Like where, we like typically to get construct validity for self-reported fear, we would look at heart rate or something like that, right? Like there's nothing like that for LMs that I'm aware of, right? I can only say that like my colleagues here in biology are building like, digital twins of the human heart and of lungs and all sorts, so maybe we're headed in that space. But some of my other colleagues I work with closely now are in robotics, and like they keep telling me we can barely make a robot walk, so how on earth is it going to, navigate a cocktail party, And I think those are the questions that, when you hear people like Jan LeCun say, LMs have the intelligence of a cat or don't even have the intelligence of a cat or have the intelligence of a 2-year-old, right? Like I think they're referring to this broader, behavioral realm or visual realm. And so I think a lot of this work on world models will be really interesting to keep our eyes on as social scientists. Historically, we've been really bad at thinking about the embodiment of things. I think that's because we're just so used to like having convenient data sources. It was like very convenient to pull your data from Twitter and pretend this was what's actually happening, right? Like I think many of us are guilty of just saying social media is real life. But the more you study people in real life using social media, the more you realize you're missing out on these huge parts of the equation. So I think you're asking a very good question. Unfortunately, one again that I don't have a great answer to. But yeah, be neat to see people take this on, maybe at the Summer Institute.
With that, I think we can again thank you so very much for this really brilliant talk and discussion. And I need to correct myself. I said it's the third. Actually, it's the fourth and last talk of the fall 2025 semester CSS seminar series. So we have a really exciting list of talks for the spring semester also. So I'm inviting everyone to follow our LinkedIn page. We'll be posting more details there, along with more information on how to apply to the SICSS Istanbul. Thank you, Chris, so very much. And
You're very welcome. Yeah,